So, good morning everyone. In this video, we are going to discuss about the next scheduling algorithm, which is rate monotonic scheduling. So, this rate monotonic scheduling it operates depending upon the priority that is given to each and every process, and it is preemptive in nature. That is the process which is currently executing in the CPU. It may be taken out whenever a new higher priority processor is available in our ready queue, and the priority it is decided based upon the cycle time of the process, which are all involved in this process execution. So with an example, we can discuss in detail about what is rate monotonic scheduling. So here we have taken three processes and their execution time and the time periods. So here P1, P2 and P3. Among these three processes, P1 is having an execution time of time period 20, which is largest one, and then we are having P2, which is the least one among the three, which is 5, and P3 is having an execution time of 10. So this time period it indicates how long the process will be repeated again and again in the process execution, right? So the main thing that we want to do here is to find out the overall LCM, that is the least common divisor of the given all the three processes. So when we find the LCM of these three, we will be getting it as 20. So the maximum time of execution that may take for any process is about up to 20 millisecond. Okay, so that's why we have plotted the range from 0 to 20, and then each process the execution time is represented here. That is, for P1 it is 3, for P2 it is 2, for P3 it is 2. So we have drawn that using a line diagram, that is a chart which tells us about the each process execution time in this 20 millisecond plot. Okay, so for example, for P1 the total execution time is 20. In that 20 time period, P1 will be executing for 3 seconds and P2 will be executing for 2 seconds in every 5 interval of time. So P1 will be executing for 3 seconds in every 20 interval of time, and P3 will be executing for 2 seconds for every 10 interval of time. So this is how here we are representing this with a line chart, that is P1 from 0 to 23 seconds it will be executing, and P2 will be executing for every fifth interval of time it will be executing for 2 seconds, and P3 for every 10 milliseconds of time it will be executing for 2 seconds. So from 0 to 10 it is 2, and from 10 to 20 it is 2. So likewise we have plotted the different execution times of each and every process here independently. Now how it works, let's see that. So starting with 0, now the priority is it is decided by comparing the time periods of these three processes. So when we compare the time periods of these three processes, which one is having the least time period? P2 is having the least time period among these three. So P2 will be getting the highest priority, and then comes P3, and then comes P1. So at first we will be giving P2 to the processor. So what is the execution time of P2? So as we see here, it is 2 milliseconds. So 0 to 1 P2 and 1 to 2 P2. So at the next priority, highest priority process is P3, because it is having a time period of 10 seconds. Therefore we are giving the CPU P3 process. So from 2 to 3 and 3 to 4, P3 is getting executed. So at this time, the next priority, higher priority process, which is P1, is coming inside. So P1 is having an execution time of 3, and 3 P1 will be given to 4 to 5. At this time interval, P1 will be given to the processor. But at the end of the 5th millisecond, we have to see, we have to look into if there is any higher priority process coming in. So when we, because the first fifth interval it has been completed, for example, this part has been completed and this part is being completed. Okay, and in this P3 about 1 millisecond has been completed from 4 to 5, so remaining there are 2 seconds more. Okay, but at the end of the fifth second, again we have to check the priority of all these three processes, because the first 5 interval is over now, so we need to go for the next fresh 5 interval. So when we consider this fresh 5 interval, we need to again look into the priority of these three processes. So when we check the priority, again we are having a higher priority process called as P2. So P2 will be given the control of the CPU, and P1 will be preempted from the processor. So this is the change that we are making here. So P2, as usual, it will be continuing in the processor for its execution for about 2 minutes, for 2 seconds. So from 5 to 6 and 6 to 7, P2 will be having its execution. But as per our priority list, after P2 there should be P3 in the order, right? But why we didn't take P3 in the sense, the P3's execution from 0 to 10 has been completed already in this part itself. So we should not take this 2 second again. We need to go for the preempted P1 process, which is remaining, having a remaining burst time of 2 seconds, because 1 second has been completed here. So again for 2 seconds it will be executing. So P1 will be executing for the next 2 seconds. Okay, so by 9 this 3 seconds would have come to an end. Okay, now there will be no other process in the ready queue waiting to get the control of the CPU. So at this time the CPU will remain idle, that is from 9 to 10 the CPU will be sitting idle. Now at the 10th time interval, a fresh slot it starts from 10 to 20. So at that time once again we will be checking this time period, and we will compare the least priority, that is the least time period, and we will give them the highest priority. So in our case, for 0 to 20, this 3 second P1 process has been completely completed. So we are having in hand only P2 and P3. So among this P2 and between this P2 and P3, which one is having the least time period? P2 is having the least time period, so P2 will be given the hold of the CPU. So as usual, it is 2 execute, the execution time of P2 is 2, so it will be taking the turn from 10 to 11 and from 11 to 12, and the next higher priority is P3, so it will be taking from 12 to 13 and 13 to 14. At the time, at the end of the time 14th second, this second second 10 interval 10th interval of time for the P3 process, that is from 10 to 20, the execution is completed. So P3 will be completely going out of our execution, so that there will be again a idle time for CPU here, because the next time P2 can come into the CPU is only after the next after this first 10 to 5 15 interval. So after 15th time second only P2 can be again getting the hold of the CPU. Until then it has to wait. So again from 14 to 15 we are having an CPU idle time. Okay, so now after 15 we are again seeing the ready queue, and the only one process which is available in the ready queue at this time is P2, and P2 is given the hold of the CPU. So from again 2 seconds P2 is getting executed from 15 to 16 and 16 to 17. So this is how the rate monotonic algorithm it works. So as a continuation of rate monotonic algorithm, we shall these are the advantages and also the disadvantages. So the process involved, it should not share the resources with other resources. Only then we may have a proper preemption of all the processes, and deadlines must be similar to the time period. So because the deadlines are deterministic in nature, so that's why we are having the preemption property here. And also the higher priority processes will automatically they will preempt the process which is already running in the CPU. So these are all the conditions and also the advantages that is associated with advantages and disadvantages associated with the rate monotonic scheduling algorithm. And moving on to the next scheduling algorithm, you are having LLF, that is least laxity first scheduling algorithm. This we may discuss in the next class. Thank you.